Hi, folks. Welcome to Cult's 2019 Open Problem Session. The Open Problem Session is something that's very unique to Cult, and it's been going on for many years. Does anyone know how long it's been going on for? I actually don't know the exact number. Many years, since I've been coming to Cult for over about 15 years. Just to summarize, just for folks who don't understand this system or haven't seen this before, an open problem, which is published in the proceedings, it's not really a formal publication. It's typically a statement of something that you try to solve but were unable to. And I would like to make a point that, we got roughly about nearly 10, I think, 10-ish submissions for the Cult Open Problems. It was a little bit competitive. We took about 6 of them. But I want to invite folks to I want to invite you guys to submit more open problems. I'm surprised, given the number of publications that we have at Cult every year, how few open problem submissions we have. You should really think of a submission for open problem as like a replacement for the research trash bin. Obviously, we don't all solve all of the problems that we try to, and of course, when you don't solve a problem, it's a good idea to try to invite others to try to solve the problem in your place. And as Manfred told me earlier, actually the best reason to submit an open problem is basically to distract the sheep and make them go over there so that they don't solve the really interesting problems. So you can use it as a distraction device as well. I will mention, typically, it is very typical that people will put a bounty on their open problem, so they'll put a reward that will be paid out personally. And my understanding, at least according to Manfred, that the current record for the highest bounty that's been placed, that I believe has not been paid out, Manfred? No. Is $600.
Totally safe.
It's safe? What do you mean it's safe?
Safe investment, because nobody will solve it.
No one's going to solve it. Okay. So then the point he's saying is that we should try to outdo that this year. So among the 6 open problems, hopefully we'll have a chance to at least do 650, 700, maybe 1,000. Okay. So to get started, we have our first speaker actually is not one of the official authors of the open problem. We have Daniele, who's going to discuss Filippo and company's open problem. And I believe that Filippo told me that you're going to put a large bounty on this problem, and you're going to, on your own, yeah. Okay, good, good.
Okay, hello, I'm Daniele Calandriello, and this is not joint work with Filippo Perrotto and all the other people, because unfortunately his visa was denied, and I'm here presenting, and I have the honor to tell you why the risk of ruin in Multiarmed Bandits is an important open problem. So if you were here yesterday for the Bandit session, you probably have seen this plot a lot. This is cumulated reward over time, and you have 2 different strategies. In blue is the old boring strategy, and in red is your new fancy strategy that is clearly better because over time is going to end up accumulating more reward, and more reward is always better. Here, what we are trying to say is that there is actually some hidden problem in this framework that says, what if you set up a budget for your algorithm, and if you go under this budget, you're just ruined and you cannot continue playing. This is a classical case when, for example, you have a budget in money and you're doing investment, or you have a budget of days and you're trying to secure a visa. So the current standard stochastic multi-armed bandit setting is designed to study the exploration-exploitation dilemma. And this is to say you have K arms. Each arm has an associated reward distribution that when you pull the arm is going to pay off you some rewards. And you have to balance between exploring to find out which is the reward of each of these arms, and exploiting, which is pulling the best arm that you've estimated so far. The goal, usually specified, is to minimize the regret, where the regret is just the difference between the reward that you are accumulating and the reward if you were pulling the best possible arm. But turns out that this model is very nice to study this exploitation dilemma, but it has its limits. For example, I still haven't found a slot machine that doesn't require payment to pull an arm. That's why Filippo tried to propose this survival multi-armed bandit framework, where you have the exploration safety dilemma. So it's an even bigger dilemma. And instead of keeping track of your regret, you keep track of a budget. You start with a budget B0, and at each step, you get a payoff RT that can be positive or negative. And the things become interesting only when you have two arms, one which has unexpected reward that is positive, and one which has unexpected reward that is negative. And so you either end up in a situation where eventually you're going to find this best arm and continue profiting forever, getting infinite reward, or you might end up hitting the negative arm because of uncertainty, and you're going to end up ruined. And which one it happens, it depends on your strategy, and you end up with a multi-objective optimization problem, where not only you're trying to maximize your budget, but you're also trying to minimize the probability of ruin. This makes it more interesting because now you don't have only a single optimal strategy, but you have a whole Pareto frontier of optimal strategies that you can try. And it's already hard to define the equivalent of the regret in this new setting, because before we knew we wanted to minimize regret. Now, for a survival MAB, what's the right quantity that you want to minimize in this trade-off between safety and reward? Of course, it's not that the stochastic multi-armed bandit is the only model that ever existed. There are other models that try to capture this uncertainty. Risk-averse multi-armed bandits try to find arms that are more concentrated around high payoff, so that you risk a bit less. But they don't have the concept of a budget. Like, you're still getting your rewards and you don't have any limit. You cannot run out of money. Budgeted MAB are closer in the sense that there they keep two kind of function. One is the cost of pulling an arm and one is the reward, but the two things are uncorrelated, and there what you try to optimize is find the arm with the best ratio. Here you don't really have a ratio because each arm is really giving you either positive or negative quantities, and you can run out, and if you run out halfway through, the objective is not to allocate as best as possible your budget. Your objective is not to run out of budget during the strategy. And so it's not clear what would be the solution or how if you can reduce any of these algorithms to this setting. If you want more information, you can just go on the paper or email directly the author as he wishes. Thank you. I can try to take questions, but if it's too hard, I'm just going to jump off and run in the distance. Okay.
Okay, let's thank Daniele again. Next up, we have Vitaly.
Thanks, Jake. And I'm going to present actually two distractions. And I can offer certainly for significant progress on any of those, I'll offer a nice dinner with the authors of the open problem. Depends on the quality of the progress, right? No, during the conference in a nice place. Okay.